Okay, after finishing this exercise, I would like to pass to exercise 2. This is exercise 2. Okay, so I take a copy of this exercise 2 as an image. I put it here. Okay, just because I would like to load it. Sorry. Okay, I would like to load it in my image here instead of this exercise. So I'm gonna say make a copy, save this. So this is already saved as exercise 1, and I will send it to you. So save this notebook as, I'm gonna rename it as exercise 2. Okay, this is exercise 1. Okay, this is exercise 2. So instead of loading this image, I'm gonna load this image. Okay, with the same size. So run this. So this is the new image. I don't need this. I'm gonna remove all this. I don't need it. Okay, I'm gonna delete all this. Okay, starting from here. Good. So in this exercise, so this exercise is mainly will permit you to create a certain familiarity with Matplotlib libraries, how to draw functions, etc. This is the main idea. So the idea is to write a script in which you define the functions f of x equal to sine to x, gx equal to cosine x, and h of x equal to cosine to x. These are classical trigonometric functions, and we would like to define these as a function. So the same idea is always how to define functions, how to manipulate functions, etc. So these are usual functions, so they are already defined in the libraries, but we will see in the next exercises, I don't know, 3 or 4, how to create customized functions using if, using conditions, etc. So, and in the second question, would like to draw on the same graphic, on the same plot, in the interval minus 5, 5 for x domain, these function f, g, and h, and add legend, title, label, etc. So we will use the library matplotlib. Okay, so let's start. So first of all, we will import the library NumPy as NP as usual. So since we will deal with plotting and drawing curves, etc., we will import the library matplotlib, and you have two options, dot, and there's in this library is a submodule called pyplot as plt, or this is one way. The second way is like this: from matplotlib, okay, import pyplot as plt. Okay, so you have two options. You can use the one you like the most. Okay, so this is concerning importing my functions. I would like maybe I would like just to be I would like to create here my functions. By the way, these functions can be created separately in a different script, and in the script I can call it my functions, and I can import it also as if it is in the current directory, or I should add it in the path of Python libraries if you want to generalize this independently of the folder you are working in. سو يعني لو انت حابب تشتغل فقط في اللوكال فولدر هذا، خلاص ممكن تسجله في فايل سيبريت وتستعمله. if you want to generalize this وتفتحه من اي مكان الفانكشنز دول لازم تضيفهم في الليبرري تبع بايثون. اوكي so okay, let's start. So define the function f, and okay, maybe it is better. Okay, I'm gonna call it f, which is not really smart. In the practice, it is better to give it a my f or something like this. So f, the input is x. Okay, so this function f has an input x, and it returns directly without any. Return. Okay, the f of x return. Okay, return the value sine no np dot sine 2x. Okay, so certainly I'm not in the obligation to use the library NumPy. In that case, you will call them. There's another library called mat, and you can call the library mat and use directly mat.sinex or something like this. So this is for f. I can do the same for g and for h. So this is f, this is g. G is equal to cosine x. Okay, cosine x. And for h is equal to cosine 2x. Now these are my functions, are well defined, etc. So I define these functions. Everything is okay. So I would like to draw my functions in this interval. So for that, my vector x will be defined in this range. So look, you have too many ways to do it. So I can define a vector x as an np dot, and this vector will be in the area between -5 and 5. So I can use lean space. So I create a linear spacing between -5 and 5, and I would like between -5 and 5 like 50 points. Okay, if I put one, sorry, if I put let's say 5 points or 7 points, I will have the following as a result. Maybe I should it should be better to print x just to show you if you use the command linspace. So 1, 2, 3, 4, 5, 6, 7. So if you use 8 or something like this, you will have the following result. You have 8 values, 10 or 11 values. Okay, so -5, -4, -3. So if you count this, if you count the length of this, it's equal to 11. Okay, so this is one way. I'm gonna take 50 or maybe more. Okay, so this is my vector. So it starts from -5 to 5. Okay, you can use also, for example, I can use x1, which is equal to np dot a range. Okay, and I'm gonna start from -5 to 5 with a step of 0.1, for example. Okay, if I print x1, let's do it for in the beginning with the range equal to 1. Okay, so if I draw x1, this is my result. So this is x1. Okay, so from -5 to 5 with a step equal to 1, and at the end you will not take this. The difference between this one and this one, that here you define how many points are linearly spaced between each other in this interval -5 and 5, and 5 is included and -5 is included. In this case, the 5 will not be included. So I can define, for example, here a time step of a space of 0.5, and you will obtain like this: -5, 4.5, 4, etc., until you reach this. If you take 0.1, so you will have this. Okay, so it's a step of 0, -5, -5, 4.9, -4.8, until you reach 5 without touching it. Okay, it's open from the 5 here. It's open. You can't touch it. You can't reach it. This is the difference between. You can use linspace or a range. It's up to you. Both of them are NP arrays. Okay, so I'm using linspace in this case just to show you that this works. So I'm gonna comment this also. Now I would like to so I don't need to print. I'm gonna remove this. Okay, just to be clean. So this is my x. Now I can draw my functions. Okay, so my outputs can be f1, okay, or y1 equal to f of x, y2 equal to g of x, and x, so it is defined like this, and y3 is equal to h of x. Okay, I can run this. Okay, oops, where's my function? uh, I made a mistake here. Here it's h, so I can run this again, no, it's okay. Okay, so after doing this, I would like to, as it is mentioned, we would like to print or to plot. We need to plot these functions. So we will use the library matplotlib. So you will say that. So the best way is to define a name for a figure. So I will create a figure called, or you can start directly, plt dot plot. You can see you have a lot of options, but you will see plot. So you have x and y1. This is the function f. And if you run this, okay, so you have the function f. So as you see, it is not really smooth. If you add more points, it will become smoother. For example, 100. So in that case, your result will be smoother. Okay, you will have a smoother result. So you can plot xy1 in the same time. If I take, for example, and I would like to plot y2 and y3, for example, if I do this, xy2, okay, and run this again, so you have x y1 which is equal to sine of 2x, so it is two time, it has the double of frequency. So if you want to add also y3, it have the same frequency as f. So this is y3, and this is, okay, these are your results. Certainly now you need to specify which is what, which one is the function f, which one is the function g, which one is the function n, and you need to add axis here, here an x label and a y label here. So you should, but I prefer not doing like this. I prefer coming here and define first of all a figure called figure one, plt dot figure 1, for example, and run it like this. Okay, so here I'm drawing in the figure 1. So I would like to add also a text for the label, a title, a value here. So for the x-axis, I'm gonna plot dot x label. So it is defined like this. This is how, if you want to write something here. So I'm gonna write, so x-axis. So if it is something in meter or second, you will write that in second or something like this, or in meter. And when you run it, it will appear here. Okay. So since here it is dimensionless, you will keep it as it is. For the y-axis, you will write that it should be y here. So the y-axis, for example, you can write anything you want. Maybe it is a pressure, or maybe it's a temperature, or a concentration in ppm, or anything. So if you run it like this, so you can add a title, okay, here, for example, and we can modify the position later on. So you will write that plt dot title, okay, and you will write my first functions f equal to sine 2x, g equal to cosine x, and h equal to cosine 2x. Sorry, cosine 2x and cosine 2. to sorry, to x closed like this, and if you run it, no, I didn't close it here. Okay, so if you run it, okay, my first function, so, and I have, and you can save your figure in the current directory, or you can keep it like this. So what else? We can add also a legend. So you plt so dot legend, and here I'm gonna create a list, or maybe I can even create the list before. Here I'm gonna call it txt equal to, so this is my list. So the first function is f equal to sine to x. I'm gonna put it like this, comma g, okay, comma h. So this is my, and this text I will insert it here in the legend, okay, just to be, okay. So like this I inserted my legend. So certainly what is better now is to move, to have an option. We look to the options here, and to move the position of this legend from this position to the top here, or to the top right, or to the top left. This is concerning the, maybe I would like to go up, okay? So this is what is needed in this exercise. And maybe we would like to see how to move this from this side. So in order to see how to move this up or down or anything, we can come here, and this is my, I can copy the function legend, okay? And come here and do help, and try to look at the help of the function legend. So if you look here, again down in the for the position, maybe I can do like this. So if you look in the different parameters, these are the location in strings. The best, it means location is best. So you should specify that the position, the parameter is lock, okay, and you add one of these. So we can try it now. So this means that in my function here, wait, in my function here, we should add lock equal to, for example, best. So in this case, the matplotlib will choose for us the best position. So for by default, this is seen as the best position. We don't want this. I would take the upper left or the upper right. Okay, I'm gonna take this. So let's try this. Upper right means that you want your the position becoming here. Okay, I'm gonna remove this. Okay, so if you run it now, okay, so it comes at this position, and this is what is needed. So you can specify. I don't know if you can use a number. Let's try with the number. Okay, yeah, you can use the number because it's mentioned. If you use the number 2, I think you have a list. Okay, here you have 3, okay, etc., and you have different options, and you can play with it.